Welcome to the video on calculating confidence intervals and sample sizes for proportions. This is section 8.3 from our textbook. We're going to run through an example. At the beginning of the semester, we conducted a Coke versus Pepsi taste test. Business 205 students have been conducting this experiment for the last several years. A common question that has arisen is whether people really prefer the beverage that they perceive to be their preference. In other words, does their perceived and revealed preferences match? Over the last 3 semesters, I have found that 58 out of 95 people had a revealed preference that matched their perceived preference. Suppose that we're interested in calculating a 90% confidence interval estimate for the true proportion of people that would match their perceived to revealed preferences. So we're looking at 58 out of 95 people for our sample proportion. Can we assume the distribution of the sample proportions is approximately normally distributed? We don't have the true proportion, so we're going to have to use the sample proportion in its stead. Remember, the rule is such that if n times the proportion is greater than 5, and n times 1 minus the proportion is greater than 5, those sample proportions p are approximately normally distributed. For our case, 95 times 58 out of 95 is 58, which is greater than or equal to 5. Check. 95 times 1 minus 58 out of 95 is 37. That's greater than or equal to 5. Check. We can assume the sample proportions are approximately normally distributed. Now that we know the sample proportions are approximately normally distributed, we can calculate the 90% confidence interval for the population proportion of people that would correctly identify their perceived preference. In other words, we want to find a confidence interval estimate of pi, a range inside which we're pretty sure pi falls. To calculate the confidence interval, we take our sample proportion p, plus or minus our critical value. For proportions, if the proportion is approximately normal, we use the z. If the proportion is not approximately normal, this formula no longer applies. We take that critical value and we multiply by the square root of p times 1 minus p over n. Remember, this is our standard error. So let's do that with this example. 58 out of 95 plus or minus 1.645 times the square root of 58 out of 95 times 1 minus 58 out of 95 over 95. That 1.645 comes from doing norm.s.inv, and the probability that we use is half of the probability that would be outside the confidence interval. So if the confidence interval is 90%, then we use 10% divide by 2, and then we really just take the absolute value of that. So 1.645 goes in where the z value is here. We can calculate the confidence interval in Minitab. If we go to Stat, Basic Statistics, 1 Proportion. In the drop-down box, you'll need to change this to Summarized Data. We do not have a column of data that we're analyzing, but instead Summary Statistics. Enter these numbers in the way you would write the fraction. The number of events, 58, out of the total number of things that we try, 95. So 58 people out of the 95 people. This is always written in proper fraction form. Before you can hit OK here, go into the options box and change the confidence level. We need to change this to 90% since we're trying to calculate the 90% confidence interval. You also need to change the method from exact to normal approximation. Hit OK, hit OK again, and we'll get our confidence interval. As you see here, the computer automatically does all of the math for us. It calculates the critical value that's appropriate, it does the standard error for us, and it does the plus and minus. So we don't need to do any of the work ourselves. In fact, just punching these buttons on Minitab allows us to quickly say, we are 90% confident that the true proportion of all people that would match their perceived to revealed preferences is somewhere between 52.8 and 69.2. Now, if you look at that range, that's actually almost 17 percentage points. Our margin of error is quite large here. The margin of error is plus or minus 8 point something, almost 9 percentage points. That's a very wide confidence interval. So suppose we want to narrow that confidence interval. Suppose this confidence interval is not as precise as we would like it to be. What sample size would we need to create a 90% confidence interval for the true proportion that has a margin of error of plus or minus 4%? The formula for this is an n equals. Anytime you're trying to find the sample size, you're looking for an n equals formula. We'll do n equals the critical value squared times the variance. P times 1 minus P is the variance of the sample proportions. When we did this before, we did the standard deviation squared. Well, the variance is just the standard deviation squared. And the denominator is our margin of error squared. So let's plug in the numbers that we have. N equals 1.645 squared times 58 out of 95 times 1 minus 58 out of 95. And then we put our margin of error in decimal places. Since these are really fractions or proportions, we need to enter this in also as a proportion. When we simplify this fraction, we get 402 and some change. We always round up, so we're going to use a sample size of at least 403. Since we've already sampled 95 people, we only need to take a sample of 308 more people to reach our goal of 403. This would allow us to generate a confidence interval that is much more precise. Thank you for watching, and I'll see you again soon.